question that I have is, in my head, could you ever draw this curve as a useful tool to predict where you should go prior to an event occurring? It seems very retrospective. It only tells you what just happened. It doesn't tell you what you should be doing.
One of the things about the critical functionality curve is that you can only calculate the severity of the event after the recovery, which means that Dan has a point. The critical functionality curve is fundamentally retrospective. Although it helps us understand the concepts and the vocabulary of resilience, it doesn't tell us what are the things that we should do when we're experiencing the event, or how do we organize our system in case we're surprised by the event. So we're going to talk now about the limitations of the critical functionality curve, and finally we're going to introduce an alternative to critical functionality that's going to be a more advanced way to think about resilient infrastructure. What else can we say about the limitations of the critical functionality curve in addition to the fact that it is fundamentally retrospective?
Well, one thing that I also don't really appreciate is it tends to emphasize this notion of recovery as being the focus of resilience. I mean, if a system's going to be resilient, plan and preparation is this flat line, and there's no real indication as to how to better plan and prepare or how to better recover relative to that planning and preparation. It's essentially saying more planning and preparing, better absorption, better recovery, and better adaptation is always better. How do you prioritize these different things? The curve only really shows recovery having an effect and absorption having an effect, rather than adaptation or planning and preparing having a real big effect on what resilience means. Where if we're truly resilient, wouldn't this line be relatively flat? We need to plan and prepare really well.
What Dan connects there is this idea that the shape of this curve, we only see, in some sense, the consequences of having appropriately planned and prepared, but it doesn't tell us how to plan. It doesn't tell us how to prepare. It doesn't tell us how hard we were working to absorb or what we could have done better.
Yeah.
So in that sense, it's not particularly useful as a tool for thinking ahead about what we might do to make our systems more resilient. There's another thing, though, that I think is really fundamental to this curve, and that is the notion of function to begin with. So here we've very cleanly defined this notion of function as though it were a single number that we could measure, kind of like a thermostat or a speedometer or something, where it's just a very clean number and more is better and less is worse. In practice, infrastructure function has many different dimensions to it. There are lots of different attributes, and it's not quite so clean to look at this. So while as a cartoon, it allows us to think sort of in a quantitative way, in practice, what the function of a particular critical system might be could be very, very different. And the shape that this curve has as a result might be very hard to quantify and typically doesn't look as clean or as nice as in this picture.
Yeah, one example I could think of right now off the top of my head is a dam. The critical function of a dam can be either water storage, how high can the water be behind it, how big of a reservoir can you make so you can store water, and also water release. How low can you put the water to try and get people downstream to have drinking water? So this conflict between both flood management and storage and water release and water provision, those are both functions that dams provide that are potentially going to draw exact opposite curves depending on how you define this vertical axis.
Well, and I think what you get at there is this notion that what matters about a critical infrastructure might be different to different people, to different perspectives, right? So for ranchers and farmers downstream of the dam, it's all about making sure that that supply is uninterrupted. For the population that lives below the dam, it's about making sure that that town, that city, is not flooded. For towns farther away, it might be about making sure that there's clean drinking water and other sorts of things. So that notion of function, again, might be different for different stakeholders, and as a result, again, it's not quite so simple. Now, there are ways, scientists, mathematicians, engineers have come up with ways of bringing these different kinds of functions together mathematically, multi-attribute, multi-objective sorts of things that then have the appearance of providing something that's maybe a bit more integrated, maybe a bit more clean. They get more complicated because now you have to decide how you weigh one thing against another. And when you make it more complicated, although it has the appearance of more mathematical rigor, it tends to obscure what's going on. It tends to hide it as opposed to illustrate potentially what's going on.
There are two other shortcomings that I'm reminded of as you are talking. The first one is that the event in this kind of timeline is always imagined as an acute event, such as a hurricane or a power failure, at the expense of overlooking chronic stressors. The word event suggests that it has a beginning, it has a sudden onset. But we must also be resilient to those things that are always going on. They might be sea level rise, they might be deforestation, they might be events that creep up on us and accumulate stress rather than this episodic acute imposition of stress.
And I think even more importantly, Tom, this notion of the curve and the function up to this point suggests that everything was fine and stable in a nominal way without the need to be working to absorb, right? That absorption only happens in response to this acute event. When in practice, the function of these systems is under constant stress and is only able to maintain its function, which is not just a simple flat line, but because there are lots of actors working in constant response to adapt, to improvise to these constant stressors. A concrete example of this might be the electric power grid, where although we might think of it as the power's on and sort of stable, in fact, load is fluctuating all the time. The system is under constant stress as overhead power lines fail, as transformers fail, as other sorts of things. And the operators at the local utility are in fact working quite hard all the time in this constant sort of event response kind of way to give the appearance of some kind of stability. And so, in fact, what we see here is something that is much more dynamic, is much more complicated, and much richer in terms of the overall story.
The imposition of the event and the word absorbed implies a response here that is too passive for my tastes. As Dave points out, all of these processes are going on all at once, even when it appears from the critical functionality curve that you have some sort of homeostasis. That homeostasis is only at a level that would mask all the adaptation, the maintenance, the repair, the learning that is going on below the surface of this curve. Then, if a chronic event does occur, it's not just that we're sitting passively by and absorbing it. We're already accelerating the kinds of responses that are necessary to ensure that we don't dip down. As to, if we could, ride out the stressor or event without any loss of functionality.
And with that in particular, I think a key word that we spend a lot of time thinking about is this notion of anticipation. Right, so it's important that not only are we planning and preparing, but we're anticipating. Right, we're trying to understand at which point we have to start working harder to try to maintain function or minimize the consequence of this potentially disruptive event.
So, how hard are we working to maintain the critical functionality curve? That is, we may be we're spending more resources, we may be losing room to maneuver, we may be working harder and harder, and the system becoming decompensated even before it loses functionality. We need to know what are the processes that are going on that maintain this functionality, and the critical functionality curve masks the underlying mechanisms of how to maintain, how to absorb, how to recover, and adapt.
So what that means is that in this simplified cartoon picture, we're not even talking about what is the capacity of this system to do all of the things that it needs to do to sort of avoid this kind of disruption to begin with.
You mentioned the capacity. I'm thinking about adaptive capacity. What's the adaptive capacity of the system to maintain functionality even as the stresses accumulate? There's also the question of the potentiality of the system. It might be operating here, and we can measure the state variables that say this is how full the reservoir is, or this is how much additional room is available in the reservoir for flood mitigation. But there's a big difference between measuring the potential of the system to move than there is saying this is the current state of function that the system is delivering. Mm-hmm. The critical functionality curve misses this idea of potentiality, of where is the adaptive capacity in the system and when is the adaptive capacity being degraded.
I know. While watching you draw that and say that, there's a question in my head is, I've never seen this curve go up. I've only seen it drop down. So if there's something about adaptive capacity, if there are events where you actually get better after they occur, how does that really get matched within this curve? I personally know of the details related to certain natural disasters, certain disasters that have happened where resilience was demonstrated. It was a catastrophe, but when you see how people use their systems, they actually increase the capacity of their system to ride out the problem rather than just let the problem happen and recover afterwards.
Let's see if we can summarize some of the limitations of the critical functionality curve. It doesn't include a measure of the adaptive capacity of the system or the potentiality of the system. It is inherently retrospective. It can only be measured after the fact. And then what that means is it has shortcomings for those decision makers who are trying to anticipate the future states they prefer and want to achieve those states by allocating the resources or guiding the mechanisms towards them. It emphasizes recovery after loss. It misses the full range of possibilities that might happen in response to an event, and it oversimplifies function. Because all infrastructure systems are multifunctional, the idea of having a single axis and a single measure of functionality is somewhat disingenuous. It is either ambiguous or it is incomplete. Have we missed anything?
It also oversimplifies the notion of everything that's happening up to and prior to the event in terms of the evolution of the system, how hard things are working, and how things are changing. Because in fact, these infrastructure systems are not in homeostasis. They are constantly changing and evolving, hopefully growing. Right, in the sense that much of infrastructure is related to sort of economic development and welfare. We want to have greater penetration of these services, growth in these services. These are all tied to economic growth. So this kind of disruption is really among part of a broader trajectory that is changing and hopefully growing over time.
Taken together, even though this simple representation of function and time gives us a vocabulary and way to think about and potentially even measure resilience that's very common in the literature, it suffers potentially from many issues that make it so it might not actually do what people think in terms of telling us if systems are resilient or not.
And more strongly, I think to some extent it creates a fiction that gets perpetrated in our vocabulary and our language about what matters for these systems and how to talk about them. And so in some sense, we're talking about the wrong things. So we need to find some way of changing that vocabulary and changing that conversation to focus on the things that potentially do matter.
If we were going to correct some of these limitations or compensate for them, we would have a way of thinking about resilience that is prospective rather than retrospective. We would have a way of capturing the adaptive capacity, the potential of the system, rather than just noticing its present function. We would have a way of generalizing across multiple functions rather than reducing to a single function. We would have a way of thinking about resilient infrastructure that captured lots of possible future outcomes, not just those that are focused on loss.